Hi everyone, Dr. Bond again. We're going to continue with our videos here in Chapter 10, Part 1. We're looking at Problem 2. We already have a video on Part A, but I'm actually having to start all over on this question because the data changed when I had to shut down my computer after the last video. But this actually is a great opportunity because I can show you how to do Part A using a different technique that's going to be necessary for us to learn how to do in order to accomplish Part B. So once again, we're looking at these data. I've already imported them over here into Excel, technology, and financial institutions. I'm going to add a blank row at the beginning just to give myself some room to work with, and we'll come back to that in just a minute. So again, we're looking at the different, is different from, means are different. So I'm going to look between the two that have the equals and the not equals, and the null hypothesis should be the side that has the equal sign. Now for the test statistics. So here comes the difference. So in this data analysis tool pack, you remember the beginning of class, we talked about this add-in, this data analysis tool pack. If you don't have it, you might want to go back and remember exactly how to add this into your course, into your Excel spreadsheet. So you go to data and you go to the data analysis tool pack that's over here. I know that on Mac it's a slightly different entrance, but you should have access to the same kind of tools. So in this data analysis tool pack, there's a couple things I wanted to point out. We're doing these, there's the z-test that we were doing earlier, and well, for two means, and then the t-test, and so that's what we're looking at right now. So the t-test, two samples, that's what we have, assuming equal variances. Part A was equal variances, part B is going to be unequal variances. So we'll select t-test, two sample, assuming equal variances, press OK. And now for the first variable, in the range where I can find the first variable is in these cells right here, B2 through B1 on B9. And then in the second variable 2, I can find these cells over here in C2 through C9. I did not include the labels, so I'm going to make sure this box is unchecked. I could have also done B1 through B9 and then checked the labels here. The hypothesized mean difference. This is the difference between these. This is the mu1 minus mu2 in our other video. So this is almost always going to be 0, unless, again, there's a hypothesized difference between these population means. Alpha is where we're going to put our level of significance. So in the problem, that level of significance is 0.1. So I'll change this from a 0.5 to a 0.1 for our alpha. And then that's pretty much it. Now I need to say, where do you want to put the output? So I'm going to select, instead of in a new worksheet, I'm going to select output range and select a range of cells that's maybe down here somewhere. So we'll put the output starting in cell B11 and press OK. So what you have here is the t-test 2 sample assuming equal variances. Here's your t-stat value, and then here's the p-values that go with it, depending upon whether you're doing a one-tail or a two-tail test. It also computes for you what the critical value is for a one-tail or a two-tail test to compare against the t-stat, and it's giving you the positive one of those t-values. So the t-stat, I'm going to look down here, minus 5.6589. We want that rounded to 2 decimal places, so minus 5.66. And then the p-value, we're doing a two-tailed test, so I'll go to the p, t is less than t, two-tailed, and so this is 5.89 times 10 to the minus 5. That means shift the decimal point 5 places to the left, so you have 0.4 zeros and then a 5. So rounded to the 3 decimal places is still going to be 0.000. And once again, we do our rejection decision. P-value is low, so we reject the null hypothesis, and there is sufficient evidence. So that's redoing part A with our new set of data, and we used the data analysis tool pack. So now we get down to part B, and we're going to do the same thing, but this time we're going to do population variances are not equal. So there's no change in the hypotheses. The null hypothesis is the means are equal. The alternative is that they're not equal. And now we're going to use just this other menu option in the data analysis tool pack. So we'll go data, data analysis, and we'll this time do 2 sample assuming unequal variances. And for the variable 1 range, we'll click and drag. And for the variable 2 range, we'll click and drag through the cells that we want. The hypothesized mean difference is still 0. The alpha is still 0.1. We're still not including labels. And now I'll put the output somewhere else on the page, maybe over here. Now, I just wanted to make a note that we have to do this one this way because if you go to the PowerPoint slides, they just don't give you the formulas for the unequal variances. So you have to use a tool like this in the way in which your book chooses to present this information to you. And that's why we can't kind of hardwire the equations doing the approach that I did in my other video for part A. All right, so I'll press OK. And here's my table. You can always kind of make this a little wider if you want to read it a little bit better. But we have a t-stat, we have our p-value, we have everything that we need. It also tells me the degrees of freedom. So now let's answer the questions. Okay, the t-stat, unequal variances minus 5.66, pretty much the same. And the p-value. So the p-value, two-tailed, 7.8 times 10 to the minus 5. Again, that's 0.4 zeros and then a 7. So rounded to 3 decimal places is still 0.000. And once again, we reject the null hypothesis, and therefore there is sufficient evidence that the mean brand is the means are different. All right, now we're going to compare the results of part A, and in both cases we rejected the null hypothesis. And we're on to the next question. All right, so I'll see you next time. We'll make one more video for today, which is on question 3.